Hello, this is David Hall of the IoT M2M Council, or IMC, and it is my pleasure to welcome you all to day one of IoT Days Spring with this panel, Is Low Power Connectivity Fulfilling Mass IoT's Potential? Before we begin, I want to cover a few housekeeping items. First of all, this webcast is being streamed through your computer, so there's no dial-in number. The best audio quality will come if you make sure that your speakers, computer speakers or your headset are turned on and that the volume is up so that you can hear the presenters. An on-demand version of the webcast will be available later today and can be accessed using the same audience link sent to you earlier. Also, materials from the presenters will be available in the handouts section of this interface on your right side. So we encourage our audience to check out that handouts throughout the presentations. If you have any questions during the webcast, please submit them through the Q&A box on the right side of your screen as well. The presenters may answer questions at the end of the session, but please feel free to ask questions at any time during the presentation. Any unanswered questions may be responded to offline. We do keep a record of your questions associated with your registration. Just a brief introduction about the IMC, for those that may not know us. The IMC is the largest trade association dedicated to the global IoT sector. Its membership is comprised of 28,000 adopter members who are individual enterprise users, product makers or OEMs, and apps developers that deploy IoT solutions. The IMC's Board of Governors includes over 25 of the most influential IoT technology companies that provide solutions for connecting remote devices in the form of hardware, software, and connectivity. We encourage any attending today to check out our website, iotm2mcouncil.org. On that website, you'll find information about the IMC's various activities and events, including in the area of IoT cybersecurity as well. Moving on to today's session, the mission of the IMC is to accelerate the adoption of IoT technology for the public good, and we look at today's session on low power connectivity as in keeping with that mission. So it's my pleasure now to introduce Matt Hatton, the founding partner of Transformer Insights, who will moderate our panel discussion today. Hello, Matt. Welcome.
Hello, David. Thank you very much. Delighted to be here. Welcome everybody to this session on low power connectivity. We at Transformer Insights go quite a long way back with this as a technology area, not least because Jim Morris, the other founding partner here, actually named that low power wide area space. So we've got a little bit of credibility in that discussion. So the structure today is we've got about 45 minutes. Each of the three speakers got opportunity to make some opening remarks on the low power connectivity space. I then have a set of questions, discussion topics to go through with Martin and Yatin, and then we'll get to some questions from you, the audience. Please do drop questions into that Q&A tab. That's invaluable. We want to answer your questions more importantly than answering mine. So please do that. First off, I think intros. So you've heard from me, Marty. Just to introduce yourself, and we'll get on to the opening remarks in a little bit.
Yeah, perfect. Thank you, Matt. I'm sorry, I was muted there talking to myself as usual.
There we go.
Great to meet everybody. Martin Jefferson. I'm a global solution architect at Globalstar. Been here a little over 17 years, and really looking forward to the chat today. This is really the bread and butter that we live every day in the satellite world. How to be very power efficient in remote locations, and to provide that connectivity that everybody just demands these days.
Excellent. And Yatin.
Thank you, Matt and David. Hi, everyone. This is Yatin Pawa. I head product management for Vodafone IoT. I'm based in the UK, and since IoT is all about scale and hyperscaling, this is a fantastic topic and opportunity about LPWAN mass connectivity. So looking forward to the discussion today.
Fabulous. Okay, so I've got the microphone first, I think, as the opportunity to just say a few words about who we are and what we do. I won't spend more than about 10 seconds on this. We're a boutique analyst firm focused predominantly on IoT. We cover some other areas, technology areas around the outside of that, increasingly a lot around AI, but also edge compute and a range of other technologies, but ostensibly IoT, and particularly within that, my focus is on IoT connectivity. We support our customers through a multi-client advisory service, reports, market forecasts, and access to us analysts, and custom research and consulting, which could be anything from marketing support stuff like white papers and webinars through to deep dive strategy reviews, workshops, support on M&A, and so on. So that's us as a firm. And more importantly, well, it wouldn't be an analyst presentation if I didn't put up a chart of market forecast, would it? So very quickly, I pulled this from our website. This is a publicly available resource on the Transformer Insights website. There's a link there to the forecast highlight page, and this is available in the downloads. So I thought I'd pull this and show it. Steady growth, no hockey sticks here. This is low power wide area technologies, both public and private, and licensed and unlicensed. So the 3GPP, 5G, MMTC lines are NB IoT, LTE M, so on. They're going to grow from about 920 million to 3.8 billion over the next decade, almost always using public networks. And other low power, which is mostly LoRaWAN actually, is going to grow from a little over 500 million to 1.9 billion. 60% of that's on public networks, 40% on private networks. So that's really just to set the scene. Big growth coming across a whole range of use cases, many of which we'll discuss during the session today. And we can hand it over to Marty.
Thanks, Matt. Appreciate that. Little background on Globalstar. Globalstar are a mobile satellite communication service provider. We operate a low Earth orbit system consisting of 24 satellites. And where we're a little different than some of the other systems out there is we use a bent pipe technology. So we go from the user terminal to the satellite in the sky and down to one of our many ground stations around the world. What does that mean for the non-techies in the group? Really, it means low latency, and it also means spectral path efficiency. So if you've got areas that you're blocked from a view to the satellite or a view to the ground station by buildings, hills, things that might be in your way, it makes it ideal for mobile applications because you got multiple targets in the sky to look at and multiple targets of the ground to get the data back to your endpoint. You see a wheel on the screen there. We call this basically our technology wheel or our business wheel, and you'll notice that at the core of everything is our spectrum. Globalstar has a globally coordinated, globally licensed spectrum, of which we have some terrestrial reuse for. Approval for in the form of band N53. That would be for taking some of our satellite spectrum and reusing it on the ground in a private 5G system. We have a wholesale business, which we do direct to device today for some major manufacturer today and operate the off-grid emergency communications through our network. And as such, we have a government business and we have an entirely retail arm for our satellite personal communicators. We were the first to market in the space and brought satellite communications to the recreational market, and that's continued to grow year over year. Our biggest group that from a subscription perspective, of course, is the IoT group. Not for any other reason other than people are just demanding connectivity like never before. We have these things in place. We have the satellites there. We have the infrastructure in place, and as people continue to go further and further out into the middle of nowhere, people are just accustomed to having connectivity now. So we're seeing that the satellite space become more mainstream, I would say, than ever before. Last but not least, we'll talk about a little thing called XCOM RAN. That's a recent addition to the Globalstar portfolio, and really it's a next generation RAN platform that is a secure, high performance private network connectivity. So think about warehousing, where where private solutions are really necessary, things that run robotics, things that cannot have interruptions, things that have coverage challenges. That's where that technology really shines. Skip over to my next slide here. We want to highlight today really the convergence between satellite and terrestrial. And we highlight that in our latest modem generation called the RM200. That is at its core a software-defined radio that supports both Cat M1, NB IoT, and the Globalstar two-way waveform in the same form factor, same single stack. That means that from a technology perspective, ease of integration, ease of design, single power supply, and you don't have some of the complexity of kind of multi radio solutions that's been the path of multi-mode in the past. This is an architecture that gives you the ability to flip back and forth as necessary, with some code space to build your own least cost routing intelligence in the device, and give you that ability to enjoy the networks that are out there, and obviously look at a network that's always going to be the least cost to move your data from point A to point B. Just a quick overview of where we play across the gamut of different verticals. Obviously, our two biggest are transportation and oil and gas. Why is that? Because typically they're the people that go the furthest off the grid than most do. Transportation is through rail or through over the road, is often a challenge with coverage issues. Oil and gas gets into the exploration side of things. Obviously, defense and disaster management. Disaster management in particular, because our infrastructure is in the sky. So, it's not necessarily subject to some of the local anomalies that happen when you get hurricanes and power outages and things like that can affect it. One of our biggest growth markets is connected agriculture. We talk about the connected cow. We talk about giving people visibility from a farm to fork application, through disease management, through estrus, through things that are something that in the past somebody would do locally, but as the farms get bigger and bigger and bigger, there's a much bigger need to make that more remote. And remote means infrastructure, and you can't always justify the cost of the infrastructure for the number of users in the particular area, and that's where satellite really comes into play. And then, of course, utilities, both on the electrical side of things through smart metering, and on the transportation of underground utilities like natural gas, propane, oil. We're always monitoring those kind of things in a non-powered environment. And I would say that non-powered environment, or as little power as possible available, is where we play every single day of our life in the satellite space. I'll turn it back over to you, Matt, for the next presentation. And you're on mute, Matt. So.
Thank you. I suspect that won't be the last time that happens. Yes, you're handing it to me only briefly, and I'm handing it straight on to Yatin. Your floor, Yatin.
Thank you, Matt, and hi again, everyone. So I'm going to talk about how at Vodafone we see mass IoT connectivity. But let me first start by introducing Vodafone IoTs to those who are not familiar. As Vodafone IoT, we are present in more than 760 networks, which means we are able to provide connectivity and coverage in 760 plus networks. This is over 230 countries, 180 countries. Across all of this, in terms of countries and networks, we actually have 230 million SIMs that we connect. And in fact, for the last 11 years, we have been the leader in the Gartner Magic Quadrant. Specifically in LPWA, we've got 130 plus networks where we have agreements or our own networks where we offer NB IoT and LTE M. So that's just to give you a bit of a background in terms of the scale and how that influences many of our decisions in terms of the products and services we roll out. and also the type of customers and use cases we look at, because it gets into a massive deployment across multiple countries, also within a country. And for us, it's a lot about how we can scale up and offer this offer connectivity to our customers, irrespective of whether it's LPW or not. Specifically on LPWA and the future of Mass IoT as we're talking today, I thought I will show a slide which has a couple of current technologies that we've been seeing now for the last let's say 7 to 8, 9 years. I think NB IoT is now celebrating probably its 9th birthday very soon, or this year. So this technology has been around for a while, and then that's so on the first on the left half of this you see NB IoT and LTE M, which is what we have existing today. And then now we're starting we're starting to talk about 5G standalone and RedCap and enhanced RedCap. And then of course um, I couldn't resist also talking or presenting something on 6G. So starting with where we are today, we've got NB IoT, of course, and this has been around for a while. It's mainly for static devices. It's possible to reach um, uh, deep down, and therefore where there is limited coverage, it's a perfect example of where we can see these devices being used. Of course, the speeds are very low, and we've seen in our customer deployments that a lot of metering, especially, tends to be using NB IoT because it requires very minimal and infrequent messaging, perhaps, as well as that sometimes it can be in basements. So NB IoT is good for that. So uh, that's the extreme left side of it. And then as you progress into better technologies, or kind of different technologies for different needs, where there's, for example, higher speeds needed in the case of LTE M, or even its cousin LTE Cat 1 base, where you can have better speeds. What it also does is gives mobility. So where customers need tracking for various equipment, whether it's logistics, whether it's other tracking and trace applications. That's where LTEM and LTE Cat 1 base has been already quite popular. Then when you start to look at what's coming next, um, of course, I'm sure most of you or all of you would have heard of RedCap, which is the reduced capability that's coming with 5G standalone, and then with 5G advanced, which is in the 3GPP release 18, which is the enhanced RedCap. And with this, we expect to see um, a much more massive deployment of connectivity and devices, simply because the technology will of course allow a lot more devices to be connected in a smaller space. And as far as the future proofing is concerned as well, I expect that especially now from 26, 27 onwards, we already see customers looking at what are the kind of modules they need to be investing in terms of future proofing for the next 10 to 15 years. And we're already starting to see customers talk about eRedCap kind of modules, which of course we expect to be backward compatible, so they will support LTE M. So again, it's a pathway to continue to grow, while at the same time not having to worry about the LTM kind of technology phasing out, because then we expect eRedCap to also support backward compatibility as far as LTM is concerned. Finally, something around 6G, which is that, I mean, of course, it's still a bit under development. I know that the 3GPP release was meant to go out very recently. I'm not sure if it has finally, but we expect this to be also a bit of a game changer as and when this comes. But I think it's obviously going to be a long time away before it starts to become mass market, because even 5G standalone with RedCap and eRedCap is going to take a few more years before it becomes mass market. But nonetheless, we're keeping an eye on the future as well. And 6G will also bring very exciting opportunities as far as mass market IoT connectivity is concerned, especially for low power devices, because we're looking at devices where the device generates or gets its energy from the radio waves itself. So again, that can be a game changer as far as the low power or the reduced battery consumption kind of devices we're looking at, which is one of the reasons why NB IoT and LTE M exist today. So broadly speaking, in terms of how we see this growth, we still expect between 2026 now for the next 9 years, let's say going up to 2035. If I take the example of Europe, where I expect by 2035 there'll be about 1.5 billion or thereabouts in terms of number of total IoT connections, and I expect that from the current roughly percentage of maybe 25-30% of LPWA connectivity, this will exceed 50%. So there is still a lot of room to grow as far as LPWA connectivity is concerned. I think we're only starting to see that it's becoming more and more mass as customers get more familiar with, as well as the fact that the module prices are now coming down and have been down for a while. So I expect that we're only halfway there, and we still have some way to go as far as achieving the potential for LPWA connectivity is concerned. Matt, with this, I'll hand it back to you.
Splendid. And there we go. We have quorum. As I said, I'll run through a few questions. We've already got some questions coming in from the audience, so thank you for those. Keep them coming in. I'm going to stick on the cellular topic for a second, Yatin, if I may, because what you were talking about has sort of triggered a couple of thoughts for me. In as much as when we talk about the sort of low power cellular technology landscape, there's kind of a two F words that come up: future proofing and fragmentation. Okay, now in terms of the fragmentation, we still kind of have an environment where NB IoT, LTE M, not universally available in every market compared to, say, LTE, and certainly 5G RedCap and eRedCap not available as well. So that sort of gravitates towards this being more of about supporting domestic markets or having multi-mode devices. It's not quite realized the universal benefit of having these technologies designed for IoT. And does that get solved? Do you agree, first of all? And does that get solved by RedCap, eRedCap, and sort of natively within 5G?
Well, when you say fragmentation, I mean, we are seeing customers who are happy purely with NB IoT. And interestingly, they are not necessarily only domestic customers. A significant chunk of our NB IoT, LTE M connectivity or customers tends to be multinational as well. Yes, the typical use case is considered as utilities and for smart metering, etc., where they tend to be domestic. So we are seeing a mix, perhaps also because of the scale at which we operate. That said, I've also seen customers who've got modules in their smart meters or smart meter gateways which support LPWA as well as some sort of 4G connectivity. But again, it's very interesting why they have that kind of thing. It's also because while the LPWA is being used more or less for transmitting the data, but they need the higher bandwidth just to do firmware updates and software updates. I suspect that will change when RedCap and eRedCap comes, because it will take care of all of that. So I think we're in a phase where we're still transitioning, but there are plenty of applications where pure NB IoT or LTE M is sufficient, and we are seeing that still scaling pretty strongly.
Okay, and the other aspect, the future proofing, we've had a question come in, and I'm going to drop that one in now because it perfectly sums it up. Somebody's asking, I've been told that LTE M, NB IoT are to be grandfathered in to all 5G SA networks. Is that still the case?
From what I know, yes, there will be backward compatibility, but of course, it's ultimately down to the module manufacturers. But I expect that's the case because 4G is not going away anywhere for a while, and LTE is going to be there for a while as well. At the same time, as I said, we do see customers wanting to look ahead for the next 10 to 15 years, and they need also a long-term solution. So yes, I believe that coexistence will be there, and we, of course, as Vodafone IoT, will continue to support for as long as our customers need it.
I mean, technically, there is certainly backward compatibility. Whether that necessarily translates into a commercial decision to continue that support from the network operator is another matter, but it is that's certainly the status. Okay, Marty, I should get to you. So, as you mentioned, satellite is largely about low power devices because it's remote connected devices and so
Correct.
on. Now, it not always, because obviously you've got a lot of the time it's kind of gateways and they're powered and so on, but a lot of it's not unpowered. So much of this must be about thinking about trade-offs between power, data, and battery life during the lifespan of any deployment, right?
Yeah, for sure. We've always, at least many years, existed in the space where we had to be self-powered in one form or another, either through some kind of power harvesting through solar or something along those lines, or to be something that's battery operated that can last multiple years. I always tell the analogy of people that just because you're battery operated and you can change the batteries doesn't mean you want to hop in a helicopter to go and change the batteries when they die. There are specific kind of impediments to getting that kind of functionality, which is why in the satellite space, we're a little bit different than the cellular guys. We try to be off as much as possible. We try to be reporting transactionally as much as possible. We try to do as much edge computing as we can to minimize the powering up of the transmitters, because typically the transmitters are your single point of the most power draw in any sort of messaging scheme. So yeah, we've lived in that space for years and years. Fortunately, battery technology has come a long way over the last number of years with and allowing us to make our devices smaller, more power efficient. But ultimately, low power is at the core of all satellite deployments.
And obviously, one of the interesting things with the two of you on a panel is to kind of think about the overlap between the two, hybrid type connectivity. And there's been a range of, well, not a range. There's been attempts within 3GPP to introduce this non-terrestrial network satellite as an option, effectively narrowband IoT from space, and obviously at Globalstar you have your own approach. Thoughts on the two different approaches? It always strikes me that within satellite, what you want is super optimization, and sometimes standards doesn't necessarily lead to perfectly optimized technologies. But I don't want to put words in your mouth.
Yeah, no, precisely, Matt. Typically standards are device centric, not necessarily network friendly. In many cases, I think we all, terrestrial and satellite companies alike, are looking to maximize revenue per megahertz of spectrum that we have available. And as such, if you're in control of a private solution or a private proprietary waveform, then you can be in control of both the device side and the network side. Having said that, though, obviously, we're not blind to the NTN discussions that go on in the world. And ultimately, mass market is something that everybody is interested in from a carrier's perspective. We're a carrier in the sky and ultimately want to fill the network as much as possible. I think from a business perspective, the one thing that doesn't get a lot of airtime is how everybody gets paid in this transaction. It's great to have a module that roams on Yatin's network and roams on the Globalstar and other people that are out there. But the reality is, in the satellite world, in the terrestrial world, you're still going to be a very high percentage in the terrestrial side of things and a much lower percentage on the satellite side of things. And there really has to be a trade-off to the economics of participating in that standards-based solution because it does involve infrastructure on our back office as well to be able to handle that type of thing, and the revenue that you're going to generate from that kind of business. You're either going to go in that direction and try to exist, or you're going to go the other direction and you're going to try to maximize the revenue per megahertz of spectrum that you have available in a private network, right? I don't think there's a right answer to it, because I think everybody's network's going to be a little different. We're a little bit unique as well because we also are a hardware manufacturer, because we have to be typically in the satellite space. We don't. Everybody's satellite is a little bit different. Where we're seeing a real uptick on the looking at some kind of multi-mode type solution is for people that are looking for a single SKU. So they don't know necessarily where they're going to deploy their hardware. They don't know if it's going to be here, there, which country, and they're looking for something that will allow them to deploy their hardware wherever. And that hardware is just sort of smart enough to choose the least cost network that's available, whether that be a cellular network, whether it be a LoRaWAN network, whether it be a private LTE network, or whether it be a satellite network. And I think when we're talking about the capabilities of software-defined radios nowadays, I think those are enabling the device, much more intelligence in the device itself, and the ability to be, kind of ubiquitous out there, that it just chooses the right network based on your use case, and can get you your connectivity regardless where it goes. There's real value in consolidating multiple SKUs into a single SKU from a life management perspective, being a hardware manufacturer.
And actually, all of these issues are more pronounced when you're thinking about low power devices, because low power typically means don't want to spend a lot of money, probably doesn't generate a lot of data, but also probably doesn't generate a lot of margin. So I think it becomes a more pronounced issue even more than others.
Yep, 100%.
Yeah, Yatin, I'd like to come to you on this one as well. Obviously, the flip side of this hybrid terrestrial satellite proposition is the cellular angle, and effectively the non-terrestrial network technology as it stands is narrowband IoT from space. That's effectively what it does. So how do you see this opportunity? We tend to think of it maybe as more of a kind of a value-added service on top of cellular, terrestrial cellular connectivity that gives you a sort of fallback if you really need it, rather than probably usage in a application where it's satellite first. But I'm not sure how you see it.
Yeah, there is, of course, we are expecting to see this convergence or complementarity, whatever you call it. And from what we are seeing in conversations with our customers, we're seeing two kind of sides of the same coin. One is where customers are expecting satellite to fill in the gaps where there isn't terrestrial coverage. So it's a predictable, hopefully predictable backup network or coverage for when terrestrial is not there, and satellite can make up for it. The other, which is equally interesting, is where customers are saying, yes, we've got terrestrial IoT, but we also want to be able to run our machines and monitor our machines and equipment, etc., in areas where there simply isn't cellular connectivity, which means zero coverage, unlikely to be there. For example, the poles, or Antarctica, etc. So I doubt we will ever go there, but there is satellite connectivity. So that's another area where they want coverage. But then customers also want simplicity. So they'd rather have one SKU as far as the device is concerned. One contract, one support number to call. So we see that many of the large customers want this simplicity, but they also want to have this complexity addressed. So I'm seeing these two which are going to move, perhaps not in parallel. I think the first one will come first, which is have the satellite connectivity serve as a backup or as a value added, as you mentioned, Matt, to make up for any black spots in the coverage. It will come with its challenges, of course, pricing being one of them, because I think it's also up to us to educate our customers what that pricing is. It is a premium. It's not the same as just normal standard NB IoT connectivity, because obviously they're getting something additional. But yeah, that's part of the journey that we're on as well.
Okay, good. Right, we've talked network technologies a bit, but what I don't want to ignore is the other layers of the stack, and actually particularly maybe the application layer, and protocols associated with that. So that might be messaging protocol or whatever. So my thinking is that effectively you need to adapt the application according to the constraints of the bearers that you have available. Now, Martin, you mentioned about edge compute. Actually, that's probably a good example where you want to do more processing on the local device rather than processing up in the cloud. If you're reliant on a highly constrained connection, whether that constraint is due to battery power or whatever.
Yep.
You talk to that a little bit.
Yeah, sure. So I mean, we've lived in this space for a number of years, where we try to get ourselves in more applications from a satellite only perspective by being smarter of what you're sending over the air. And the fact that the processing power available today in a very low power environment is quite vast. So you can actually make those decisions and only report what we refer to as the exception data. If everything is working as it should be, if the asset is where it's supposed to be, if the pressures are nominal, if everything is working properly, is it really important to send that data over a premium service, which is satellite? Probably not. You need to know about when they're not working correctly, when you have a spill, when you have a pressure drop, when you have an asset that is moving that's not supposed to be moving. And that exception reporting is really driven by your ability to analyze a number of inputs on the device itself. And the processing power that's available today through various different manufacturers allows you to do that in a very efficient power way, right? So it's not drawing an awful lot of current. You make those decisions, you go on. You also use that same sort of edge compute and that processing power to deal with the dissimilar nature of the networks, right? So the satellite network is always going to be different than the terrestrial network, different capacities, different message sizes, different speeds. And you need to be able to make that choice both from a technology perspective and a cost effectiveness perspective. Effectively, cellular has almost become free. I don't want to say that to you, Yatin. You guys still have to make money, but essentially, it's getting so inexpensive to send small packet data nowadays over the terrestrial network that it's effectively free. So it's there. You've got a big pipe compared to satellite. You might as well send all the data and analyze it at the other end, ingest it, display it, do whatever you want to do. You need to be able to have a different image or a different reporting structure in the device itself in a multi-mode environment to make sure that you're not getting, a giant bill if your device is switching back and forth because it's in some challenging environment. When I say challenging environment, it doesn't have to be in the middle of nowhere. I mean, I'll take West Texas, for example. Anybody's familiar with West Texas, depending on where you put your device, you might get cellular, you might not. It's very inconsistent. And where you put it today, tomorrow it might not work there in cellular properly. It's for some reason it's some kind of Bermuda Triangle in West Texas that it flips back and forth between cellular and satellite quite often. So you really need to have that edge compute capability to do that kind of thing. That's something that we've been doing for years to try and minimize the amount of airtime we send over the air. Seems like a strange thing for a carrier to say, but it gets you into more applications if you minimize the over-the-air traffic.
Yeah, but I'd say that's more about cost saving rather than necessarily about power saving, because effectively what you're trading off is transmit power versus processing power, right? So it's more that. Yatin, can I come to you on this one? Because actually, I think Vodafone's been doing some interesting stuff around this with data compression, and actually, I'm not sure you'd agree that you'd send all the data back and it's effectively free. I think you'd have a slightly different opinion on it than that, right?
Well, of course, our business model is on sending bits and bytes. At the same time, we do support optimizing the network or the devices, right, for data that's being sent out. Of course, we understand that with the likes of NB IoT devices, for example. It's a very small payload that needs to go out, and perhaps even smaller or similar for satellite. We absolutely recognize the need of our customers to keep the cost low. But then this is where the massive volume comes in. So of course we know that with tens and hundreds of millions of devices, and that's the very nature of these devices. That's what they will do. So it's not a surprise. Now, as far as sending the data out is concerned, I expect that a lot of that processing will happen elsewhere. It's not expected to be on the device, and with satellite coming in, which is also you know will not be the cheapest, at least to start with. I expect the same behavior. Just sending a few bytes out, and then it's processed elsewhere and reported elsewhere, and then whether it's edge computing or it's some other remote gateways, or it's some sort of AI that takes over then and determines what to do with that information. I mean, it's already happening to a large extent even now with smart meters and smart metering gateways. I think we will see that that grow with more price sensitivity, for example.
But I think it strikes me that there is an obligation, a greater obligation with the low power technologies to understand the ways in which the customer is making use of the channel, and to potentially advise on adapting the logic of the application to suit it, which Globalstar has had to work with for a long time, but increasingly it's incumbent on the mobile network operators also to have that kind of just a deeper understanding and a sort of almost an advisory capacity with the adopters, right?
Yes, absolutely, Matt. So actually, if I break that down into two parts, one is what we do on the network itself to support this sort of compression, and that's things like enabling the networks to allow proper power saving modes and enhanced data rates going back and forth. So it really helps save the battery power. So that's one aspect of savings that our customers expect, so that the devices only wake up very minimally. But yes, on the other hand, we've got a team of experts who work with the customers. When the solution is being built, and we are consulting with them on what they want. And then typically that's the stage where we will look at the exact use case and the needs that they have. And for example, just taking a random example, you might find the expert saying, look, don't do TCP/IP. Just always focus on things like CoAP and use UDP, etc. Because this is where you can save a lot of the traffic and the overheads. And then as we get into maybe satellites, etc., you're looking at NIDD as well, as again, to save those precious 20 to 30 bytes. It's amazing how significant these become. So yes, we do that as business as usual when we do when we work with our customers to find the best optimal setup, customer by customer, but then we also invest in the network to make it as minimally draining as possible.
Yeah. And Marty, that's something that Globalstar's always had to do, right? And
yes, at the device level for sure.
That can go to the cellular providers in terms of that, working with the customer on the use case as they build it, right?
Well, we have to worry about it on both ends, really, because ultimately our satellites are powered alternatively as well.
Right.
So we have to be, we have a finite amount of either solid fuel or battery power or solar power on the satellites. So we have to worry about the infrastructure and the device itself. So there's a good balance between what you turn on, what you leave on, what you turn off, what you're able to extract out. And I can tell you from a product perspective that we have in our hands, power budget's one of the very first discussions that we talk about, in any sort of application of a finished product.
Yeah, good. Right, I'm going to get some questions from the audience. So there's a few about pricing and so on. I'm going to skip over those for a bit, but okay, very specific question. Instead of using a SIM, I want to embed Wi-Fi in the device, that my dependency on cellular networks, which have issues in places like mines, and reduce that. Can I go with Wi-Fi embedded devices? I think I'm putting up. Well, Kind of, yes, but you've got to provide the infrastructure yourself, right? So that's the limiting factor there. But all good questions.
And then Wi-Fi is not terribly power efficient for running on batteries either. So that's in this subject matter, Wi-Fi is probably one of the worst offenders with batteries. So
that would be a fair response to that question. Yeah. Okay.
And Matt, just to add, sorry, I couldn't resist this, but there's also the whole backhaul. Even if there is Wi-Fi, but then how does that data being backhauled somewhere else if it's a remote place like a mine? It still needs satellite or something else.
Correct. So let's move swiftly on. My battery operated device only sends data once a day with data size of maximum 10 kilobytes. Most of the time, the cellular module will be in low power mode, or it can be totally powered down. In this use case, would it make any difference between Cat M, Cat MB, and Cat 1 bis in terms of battery life? I think, Yatin, that's a you question.
That's more for her.
Or it might be a very specific engineer question. So maybe that's one to take offline. But I don't know whether you've got a response on that one.
Well, I think the quick answer, it depends, because most 4G networks will not support things like power saving mode or EDRX for LTE, but only for LTE M and NB IoT. So between NB IoT and Cat M, it probably won't differ much if you're using only one of those. If the network conditions are good, but really if it's an NB IoT device or NB IoT chip, it will perform better in very low or in very poor coverage situations. So really, it really, I think this is something which requires a bit more specific expertise and consideration of the use case. But I'm trying to give a very generic answer at the moment.
Yeah, well, normally it's me who gets to say it depends as the answer to the question. I'll let you take that one for this one. I'll take one more of these and then I'll come back to a couple of questions that I have. Usually we talk about radio access issues, but even in one single global radio access promoted, nobody's talking about the complexity of bands jungle. Is there a willingness to get back for IoT with some limited bands used around the world, as it was with 2G, which only had 4 global bands? Well, Marty, I'll come to you on that first, because you're going to tell me actually that's not so much the case with satellite, but
correct. So I guess it is important that when you're choosing at least your satellite portion of the equation here, you need somebody that has globally coordinated frequencies, because we don't have the ability to reuse our frequencies over and over again like the terrestrial groups do. I think that the challenge we've had in the past is when we talk about user terminals and we talk about some of the frequencies that we use. Every country is a little bit different, so somebody uses certain bands for their own use, maybe their military or something like that is using a band that's in the mix here. So you have to be adaptable to be able to support, the various different bands across the world, because you're dealing with the legacy systems that are out there and things that are being deployed for private use, which varies from country to country.
And yet it's more a terrestrial topic, I think. Thoughts on band fragmentation?
Yeah, I think it's a reality, almost a necessary evil. Because as Vodafone and Vodafone IoT, we obviously operate in the cellular spectrum, and then it varies by country, it varies by region to some extent as well. So we have to cater to all of that. I think the industry has kind of, gotten used to it. Maybe we've created the problem ourselves, but I don't think it's going to go away. I think there is that different spectrums and different bandwidths and band ranges. I think we have to live with that, and as we do today.
And to be honest, the hardware makers have done a pretty good job of coping with the various SKUs of that. I don't see it as a particularly limiting factor, but there we go. Use cases in the couple of minutes we've got left as use cases. We tend to think that, okay, if you can reduce some of the barriers to entry, for instance, reduce the power consumption and therefore enable more battery powered devices, that should open up the market to a lot more use cases. So I'm interested to know in the next 2-3 years, different use cases that get enabled by having increasingly power efficient connectivity technologies. I don't know, Martin, you want to start on that one?
Sure. Really, the big change when you get into a simpler, lower power device is when the cost of the hardware and the cost of the service allows you to go and lower the threshold of the value of the asset that you want to monitor or you want to connect. And that's where we see the big change. So you could get, that sub $100 opens up an entire different addressable market of assets out there that there is value in having connectivity to. I use the great example that we've seen most recently is porta-potties, right? So you think about porta-potties out there,
Yep.
you wouldn't think this was an asset that anybody really cared about, but they are mobile assets and they do move around a lot, and they can be moved around, either on purpose or you can forget where they've been
Mm.
put. So a very simple thing that reports in once a week, once a month, whatever. Here I am. Nothing more complex than that.
Yeah.
That can last many, many years of a deployment. That's something that wasn't available just a short time ago when you had larger, more complex, more expensive hardware that's being opened up by the evolution of a smaller device that can sit in the middle of nowhere for long periods of time.
Yeah. It's a real world problem. Those companies often don't know where their kit is. Yeah. Tim, final word to you.
Yeah, similar actually observation, and good example from Martin. So we've also seen things like power tools, which are not super expensive, but again, it's the same principle, as it allows us to monitor lower cost assets as well. But what it's also doing with the reduction in modules and the cost of connectivity, that it's also allowing customers and the industry to monitor not just their top 50 assets, but their top 5,000 assets. So the volume also then helps to grow this massively. And then third, in terms of new use cases, I think with all of this available and being more ubiquitous, it allows much more massive applications or much more dense applications, whether it's around traffic management, ocean monitoring, where, it's a massive place, right? Imagine putting 500,000 sensors versus 50 sensors in an area. It allows that volume and that use case, and therefore the benefit of that into the environment and our daily lives so much more. So I think it's very exciting. It's opening up multiple dimensions as far as this drop in prices and the growth in this connectivity is doing.
Good stuff. We're past the end of our time. I still had a stack more questions which we didn't get to. We could have gone on for ages. Gentlemen, thank you. I need to hand back to David now. Back to you, David.
Hello, thank you, Matt, and thank you to our panelists as well, and most especially to those in our audience that were able to join us. We had a fascinating discussion we had, so thank you all. Please join us for our next session tomorrow, which will discuss 5G RedCap. You can find a link to the registration for that session for the IoT Days in the handouts section of this platform. So please join us tomorrow as well. So thanks, everyone, and I hope you enjoy the rest of your day.
Thank you.
Thank you.
Thanks all. Have a great day.